Hello, this is Mike at GameFromScratch, and welcome to a brand new tutorial series. Today we are going to be looking at the Haxe programming language using the Heaps framework. If you've never heard of it, Haxe is a increasingly popular, especially in the game development space, programming language for creating code that can run on many platforms. Now what happens is Haxe basically turns your code into native code. So you can compile Haxe into JavaScript, you can compile Haxe into C#, you can compile Haxe into C++, which can then be compiled and run at near native speed. It's a very cool language for sure. I've done a little bit on it in the past, but I've been meaning to jump into it in more detail. And where I decided to jump into it with Heaps. Now Heaps is a game framework made by the guy who actually created the Haxe programming language. So there is some pedigree there for sure. And to understand Heaps, what exactly Heaps is, I'll just read you verbatim their official description. Heaps is a cross-platform graphics engine designed for high-performance games. It's designed to leverage modern GPUs that are commonly available on both desktop and mobile devices. The framework currently supports HTML5 WebGL, Flash Stage 3D, and native mobile, iOS and Android, and desktops with OpenGL. So it's got pretty good support already. Hopefully more targets will come online soon. But that is the essence of what Heaps is. Now you may wonder, what is Heaps compared to, say, OpenFL? Well, OpenFL, from the Haxe developer perspective, is almost a porting layer for Flash. It's trying to bring the Flash programming model over, whereas Heaps is saying basically screw that and inventing a new framework. We'll call it a framework. It's not quite a game engine, a new framework from scratch. You can think of probably the closest analog to Heaps is like SFML or SDL with a little bit of like DirectX mashed in. It's a 2D and 3D library. It provides those in a cross-platform manner. Plus there's some more functionality. There's spreading classes, etc. We'll see that all when we get to it. There's even 3D modeling support in there. So it's a pretty full feature, but it's not a complete game engine. There's not all aspects of a game engine in there. All right, enough of my rambling. Let's jump right in. Now, first off, I want you to know there is a text-based version of this tutorial. For every tutorial I do on YouTube, there's also going to be one on GameFromScratch. I will link this down below. So any of the code we are about to do here, don't worry if you don't keep up. It is going to be available on GameFromScratch. Ditto with all the assets, etc. So if you prefer to read, I'll have a link down below. And of course, in the text version, I will have a link to a video for those that prefer video. So this is the first part, and today we're just going to look at getting started. We're going to install Haxe, we're going to set up a development environment, and we are going to create our first Hello World application, and that's basically it. From here, we'll move on to graphics and more fun stuff a little bit down the road, but you gotta walk before you can run. So let's start walking. Now, first off, you're going to need Haxe. Haxe is available at haxe.org. I just wanna go ahead into the downloads. Now, I'm gonna be doing all of this on Windows, just because it's easier for me to capture on Windows, and the IDE I'm choosing is actually Windows only. Now, you can use whatever editor you want. In this particular case, I am going to be using Haxe Develop, and this is a port of Flash Develop specifically for Haxe. Now the problem is it's Windows only. You can run it on Mac with a translation layer of some kind in the middle, like Parallels, but it is not a native to any other platform. So this is a Windows only product, unfortunately. So if you're on one of those other platforms, I highly recommend you check out something such as, I normally use IntelliJ, but their plugin is currently out of date. Visual Studio Code has very good Haxe support. Several other text editors out there you can work with, Sublime Text, Brackets probably, a bunch of them. But if you directly need something for a different platform other than Windows, go check out Visual Studio Code with the Haxe plugins available. I've linked both those in the text article as well, by the way. And then Heaps itself is available only on GitHub right now, but don't worry, we'll look at the entire process of installing it. But first, let's go back to Haxe. I want you to go in and just grab the installer of choice for your platform. So this will work on Windows, Mac, or Linux, but once again, I'm using Windows. And just go ahead and grab the installer. Very small, 3.2 megabytes. So this is a very straightforward process, by the way. So once it's done, go ahead and run it. And we basically want the defaults. We want Nico installed. Nico is like a virtual machine, sort of like CLR or the Java VM kind of thing. You don't particularly need it, but there's no sense not installing, especially when we're talking about 15 megabytes here. And then just pick a location to install it to. d:/dev/Haxe toolkit. And off you go. And this will just go ahead and install Haxe. It's very, 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 very straightforward. All right, we're done. All right, perfect. So now we can check to see how we're doing, just open a command prompt or a terminal window or whatever, and just run haxlib version. If you get a result back and you hadn't already installed Haxe, congratulations, it is now up and running and you are good to go. And really, we're almost done here. The one thing I'm not going to show you today, it's a bit of an involved process. There's not a lot of work involved. You just click next, 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 next. I'm not going to show you installing Haxe Develop. I already have this installed and developed. And if you're using a different editor, obviously you have a different process going on. If you do run into problems and you want me to do a video on Haxe Develop installation and configuration, let me know and I can go back and cover it. But I'm not covering that today. So we got Haxe now installed. All that we have left to do is install Heaps. And just go to Heaps. It's available, again, I'll link this. It's available in the link from GameFromScratch if you want to just click the downloads for it. But you just want to get this GitHub entry for the Heaps framework. And just copy that into your buffer. And then down here, we just want to do haxlib. Haxlib is like this package manager for Haxe. It's a very cool way of installing various different products. We're doing a git install of Heaps, and then the URL we just copied. And just go ahead and run that. And what this is going to do is just download the all the dependencies, etc. we need for the Heaps library. So basically, Heaps is now being installed, and we're done. That's it. That is all you really need to do to get up and running. So it's a very low overhead language environment. Compare that to the 15 gigs of install for Visual Studio, and you should probably be pretty impressed at this point. So now we've got all the languages installed in the library we need installed. Let's fire up Haxe Develop, or your IDE of choice. Now, the configuration I'm going to do is all Haxe Develop specific, but I'll show you it's ultimately just a command line that it's being generated. I'll show you that in a minute. So let's come in here, project, new project. We're going to make this one. Remember back when I read the description to you, I said it targets Flash, WebGL, desktop, and native mobile. Well, we're going to go ahead and make this one a JavaScript project. It's one of the supported targets. All right, we'll call this, what did I call you before? I don't know, we'll call it YouTube demo. The code's gonna vary slightly. I called it something different when I did the actual text version of this, but it doesn't really matter. So you just pick JavaScript project up here, and then YouTube demo there, and okay. All right, perfect. So here is our YouTube demo code up and going. Our project's pretty straightforward. So we got a bin. There is the host HTML for our JavaScript library, and down here is our main Haxe code. Here, let me just see if I can close all, but yeah, let's close everything else. So here is our entry point, and we're going to replace all of this in a second. So this is basically your program's main. Your program itself is here in main.haxe. And then over here, this is just main.haxe is going to ultimately create a file called youtube-demo.js. This is just an HTML5 like boot script loader for that actual file. And the only thing we need to add to this, guys, we need to give Haxe, or Heaps, I guess, more accurately, a WebGL canvas to run on. So we just need to make one little modification here. We need to create a canvas. So just canvas. This is just straight normal HTML. ID equals WebGL, like so. Style equals, this is just my preference. I'm just going to do it so it uses up the full screen of our browser. 100%, height 100%, and that's the end of our tag. So that's it. We just added a WebGL container in our HTML so that Heaps has something to run in. And we should be able to go ahead and run this. It's not going to do anything, but it'll fire up a browser. Oh, that's annoying. Fire up a browser page off screen. So here we go. Absolutely nothing going on, nothing happening yet, but it loaded. You see, Flash Develop has a local built-in web server for running this stuff. It's one of the nice reasons about using it. It's also got full code completion, some debugging support, etc. So it's a nice IDE to work in for Haxe programming. All right, so we've got that done. Now let's look at specifics to Heaps. And this starts with some code. All right. So let's see if I can zoom. I can. Perfect. All right. So first off, we need to bring in the Heaps framework stuff. The namespaces are all H2D or HXD or H3D. So H2D text. Oops. Oops. I'm using a keyboard. I don't. What are you doing? I don't know what command you're running. All right, I need to bring our library in first. So I actually jumped ahead a step. So we're gonna have to bring in two projects. We're gonna be using a folder called res, which I'm gonna jump ahead a little bit. So we need to configure that our resources folder is in our actual file hierarchy, and we need to bring in our library heaps so that Flash Develop or Haxe Develop actually knows we're using that. So let's get back to that step before we get into writing code. So first off here, add new folder. Now this is just doing it at the command line level. You could just create a folder using Finder or Explorer, same end result. So create a folder called res, that's where our resources are gonna go. And then just click here and go to properties. And we're going into compiler options. Now this is just creating a set of command lines for a compiler. That's it. So if you're just working from the command line, you can do the exact same end result just by running it from the command line. So we're gonna do an additional compiler. So we wanna add one here to the additional compiler options. So again, this is just a command line that would be added to your Haxe build script from the command line. So just -d resource path equals res. And that basically just says that our resources are in a directory called res. Now, this is relative to the root of our project or relative to the root of where the code was run. And the next thing we need to do is come up to the libraries here, and we're gonna add heaps. That's it. That's all the configuration we gotta do. So when we're done, apply and okay. So once again, you got there by doing right-clicking your project and going to properties. So now that we've got that done, we should probably get better IntelliSense going on here too. So import h2d dot. I screwed something here. Let me save that. My errant typing, I think, screwed things up before. So we're going to use the text module. We're going to bring in hxd.resource, import hxd.res.font. Now those will bring. And then we're using the JavaScript libraries in this case, so let's bring that guy in. So class main, okay, I've screwed something up. I should be getting code highlighting, etc. It was my fat fingering before. All right, just a sec. I'm gonna just pause and record. All right, so I made a fresh project, so I undid whatever I did with my mistake earlier with the finger extension changing. My keyboard actually died for a second and came back online and gave me weird focus. So new project created, but following the exact same steps. Now we're ready to jump in and get some coding done. So import, so as you can see, I'm getting the syntax highlighting now, so obviously whatever I screwed up before is not screwed up anymore. So we're bringing in the h2d library, and as you can see, you do get full code completion if you don't screw up whatever I screwed up earlier. We'll bring in the text library, import hxd.res. Now hxd are kind of like common libraries across h2d and h3d. They're sort of like the utility classes of the Heaps library. And finally, hxd.res.font. And I actually don't even know if we need that, but we're making a JavaScript class, so let's go ahead and bring that in. So if you haven't used Haxe at all, I'm not a Haxe expert by any means, so I'm not going to school you on how to actually use the language. But if you've done any ActionScript programming, C#, Swift, any of the more modern procedural programming languages, this will be immediately comfortable. You know, you might have to Google a little bit, but for the most sense, the language just makes sense. So we're making a class called main, and it inherits or extends the class hxd.app. So it's just basically a base class that we're inheriting. There is our thing. So first off, we're going to need an object. So this is a member variable. Type text, named text. So as you can see, variable name is on the left, variable type is on the right, separated by a colon. Now we need to override some methods. These are part of the program's lifecycle. They're called at various points within the application running. This first one is called init, and I'm guessing you can guess when it actually is called on initialization or when your application begins. All right, so there is init, and init, what we're gonna go ahead and do is a couple of things. We're gonna basically all we're doing in this program is displaying the text hello world on screen and then scaling it up for a little bit of graphic effect. But that's it. It's a very simple, traditional hello world style application. Now, first thing we're gonna actually need is a font. And that's not something I brought in. So let me just go ahead. Where am I saving these things? Projects. All right, here, let's do this the easy way. Right click, explore. All right, here we go. So that was earlier here. Oops, not bin, resource. So remember when we made the resource file? It's because I want to bring in a font file that we're going to go ahead and load. So it's wireframe.ttf. Now, again, if you go to the GameFromScratch version that I'll link down below, the direct link to this text file, to this font file, is available right here. However, you can use whatever TrueType font you want, but I needed one of any kind, so I just went ahead and got that one, and we just bring it into our project. So I'm working on YouTube 2 resource. There. So just drop a TTF file into your resource folder. Now, if you go back to your IDE, open up your resources, you will see it there, wireframe.ttf. Now, the neat thing, one of the very cool things with the Heaps library, or Haxe, I'm not sure who's actually responsible for this one, but there is runtime type safe checking of resources, and this is a very cool thing. We're about to see it in a second. So we just have this resource in. Now we're going to have to go ahead and tell it to actually go ahead and load them. It'll automatically bind them, but it won't load them itself. So we go res.init embed. So basically this is just saying init the embedded loaders for included resources like so. There's other versions of that, which we will see here. So local or pack versions instead. But we're doing the ones that are directly inside of our project, like you can see this way. So if you're using the local file system somewhere other than under your project, you would have done local. If you're using a pack file, you would have used pack. But basically, this sets up the loaders. So now this guy is bound and available to us. And this is very, very cool, because I'll show you how that works. So we're going to create a font object. And to use it, so we got this res.wireframe. So see that? It turned this font into its type automatically for us. So it bound it for us. And we want to go ahead and build one of these. So build. And we're making a 128-point version. So you can bind your resources and have automatic typing for them just using this whole res internal object. It's a very cool way of dealing with, so if you had a bitmap or various other things, they're supported this way using the resource system. Very cool. So now we've got that font loaded. Let's go ahead and use our text object. So text equals new text, pass in our font, and then we're passing in something called S2D. Now S2D is, I think, either stage or scene 2D. I think scene, but basically it is created for us by the Heaps library. There's an S2D and an S3D. They're basically the root of the 2D and 3D scene graph. So when you want to draw something in 2D, the root level container is the S2D class. And you can use S2D and S3D interchangeably, by the way. And we'll get to 3D later on down the road, and we'll cover 2D in more detail in upcoming tutorials. So that's what this S2D variable is. It's coming when we imported the H2D libraries, or when we included the Heaps library. It was automatically created for us. So it is part of the Heaps library. Okay, so that's what we've done. We basically just said create a new text object using the font we just loaded, which is our wireframe font, or whatever font you happen to use. Just make sure whichever one you use, it matches the name minus the extension. And then the scene 2D is where to actually create the text. So we basically just said add some text to our screen. Now that we've done that, let's add some text to our text. And of course, it's a charter. This has to be hello world. It's just the way things are. So our text is now hello world, and finally let's just go ahead and give it a color. Now this is a very HTML-y way of doing things. We're giving it a hexadecimal encoded number for the actual color. And if this is new to you, it's kind of alien. It's a little bit beyond what I can explain in detail, but basically this is a byte encoded, hexadecimal byte encoded version of color, where you can have 0 to 256, 0 to 256, 0 to 256. Coincidentally, in hexadecimal, FF is the same as 255. And this represents red, green, and blue. So what we're basically saying here is give this guy full red, 0 green, and 0 blue. So that's hexadecimal coding. You're going to have to look elsewhere if you need a little bit more detail on how that works. But if you've done any HTML coding, this will be immediately obvious what we're doing here. So basically, we just created a red color for our text. And finally, let's add a little bit of logic to this. We're going to do another override. So override function update. Now, unlike init is called once when your program is loaded. Update instead is called every single frame our code executes. And DT is the amount of time that has elapsed since the last time it was called. DT is short for delta. So this represents the amount of time that each frame of animation or each pass through our game loop is taking. So you can use that for all kinds of funky things like normalizing the speed of animations. We'll see that later on down the road. But just think of update as a function that is called, your game runs in a loop. It runs over and over and over and over and over again until it exits. Each time it runs, every pass through that loop, it's going to go ahead and call this update function. And part of that call is going to pass in how long since the last time it called. And then inside of here, we're just going to do some very simple, graphical pizzazz. We're going to take scale amount equals 0.0 on F. Oh, no points. I'm using way too much C-style languages. And we're just going to do the logic. If text.scale x, so we're going to check if it's, we're scaling x and y the same amount, but we're going to check for one or the other's size. So basically, we're going to say if it's scaled to 3 times normal, or not scale, so if it's less than 3 times normal, text.set scale is text.scale x plus scale amount. So really, all we've just done with this line of code is we check to see if the text is currently 3 times its regular size. If it isn't yet, then we increase its scale by its current scale plus 0.1. And keep in mind, this loop is calling over and over and over and over again very, very fast. So this text is going to scale quite quickly. Now, that's the if it is. So if it isn't, so if it is 3 times or bigger, we just want to go ahead and set it back to single scale. Like so. And that is basically it. That is our code. Now all we have left to do is, so we've implemented an app, but we don't have an actual entry point for all of our code in general. And that's something every program needs. If you've done any C programming, you know a program starts at the main entry point. Haxe is no different. Programs start. This is where your game, when it actually loads this code, when you type and run your code from the command line or double click it or whatever, this is where it all starts. It's a function called main. It's known as an entry point. It's called static function main, like so. And really all we do inside of this guy is create a main. Now a main, this guy, new main, it's just this class that we've been declaring all along. All right, so that is it. If I haven't screwed anything up, we should be good to go. I'm a little disturbed by this. I'm hoping that's just an old error. Go ahead and run. And there you see, it's gonna scale up till it's 3 times its normal size and start over. And really, mission accomplished. That is Hello World in a Haxe development environment from very scratch. We started from nothing to having our code up and running graphically on screen in just over 20 minutes. So Haxe is a very capable language, very approachable syntax. If you've done any C, C#, Java, ActionScript, you name it, it should look very, very familiar to you. Obviously, if you're from a Flash background, it'll look incredibly familiar because that is the source of inspiration behind a lot of the language in the first place. That's it. So basically, once again, there is a text-based version of this tutorial as well. So if you missed anything or you need to get caught up on some of the source code, for example, it's all there for you. This is it. We're done. So stay tuned. Next time, we're going to look a little bit more at graphics on screen. We'll play with the 2D graphics a little bit more. I hope this was interesting to you. I hope you'll keep tuning in. If you did enjoy this, please consider subscribing. We do this kind of content, news, game development, reviews, you name it. So if you're into game development, I hope this is the perfect channel for you to follow along. I hope Haxe looks interesting to you. I hope Heaps looks interesting to you. Of course, your comments and feedback are always appreciated. Let me know down below. And just so you know, I've actually got another series working on in tandem to this one, along with the ongoing reviews, etc. You should also see a Game from Scratch using Godot series popping up soon as well. So this isn't the only series that's going to be going on, but there will be several more parts to this series, so please stay tuned. Again, your feedback is always appreciated, so leave it all down below. See you later. Goodbye.